Okay, so here are some examples of adding and subtracting with unlike denominators. And we're going to be using the method of the least common multiple. So in order to add, we need to understand the factors of both of our denominators. So let's factor our denominators here. So here, 7 over 9x squared. The thing is, I can't factor that any more than what it already is, so I'll just leave it as 9x squared. Plus x over, now here I can factor 3x from both terms, and I'll be left with x plus 1. Okay, now this is the point that I was trying to make earlier in the other video about using the least common multiple. I'm going to look at my denominators and see what could be the least common multiple and just multiply the sides that need it. So like right here, see how this has a, this is 9 and this is 3. So my objective here is to get the same denominator, which means they all have to have the same factors. So here's a factor of 9 and then a factor of x times x. Here's a factor of 3 and a factor of x and a factor of x plus 1. So look at what's missing from both sides. So over here, I don't have an x plus 1. Over here, I need an additional factor of 3 and an additional factor of x because I need to get 9x over here. And again, I need to get x plus 1 on the left side. So on the left side, I'm only going to multiply by x plus 1. So I'm going to multiply the numerator and the denominator by x plus 1. So I multiply this by x plus 1, multiply the denominator by x plus 1. So then I get, if I distribute this inside to both of those, I get 7x plus 7 divided by, honestly, I think it's good practice to not distribute in your denominator. Maybe not now anyways. So I'm just going to leave it as factors of 9x squared and then x plus 1. Now on the right side, like I said, I need to multiply by a 3 and a 3x, because if I do this, I'm going to get 9x squared here, which is what I have over here. So then when I do that, I multiply this side by 3x squared. That's going to, or 3x, then I'm going to get 3x squared divided by, and then here I can multiply these together to 3 times by 3, which is 9, and x times by x, which is x squared, and I still have the x plus 1. So you see, my least common multiple is this term right here. I got my least common multiple. So now, if I now I can add the numerators together. So this right here is a quadratic, so I want to write it in standard form. So 3x squared plus 7x plus 7 divided by 9x squared and x plus 1, because now I can get rid of the double, I guess you could say, rational expression, and put it into one rational expression. Okay, and then right there is what you have. So now you have to think about whether or not you can simplify just a little bit further, which I don't think you can, because I don't think we can factor this one right here. So that would be it right there. Okay, now again, you could have gone the route. I'll show you what the alternate method would have looked like. So method 1, which is the definitional way. So up here, it would be just multiplying this by the denominator on the right side and multiplying this side by the denominator on the left side. But I'll show you here why that's not really preferred. Because then I'd have to multiply this side by 3x and x plus 1. So I'd have to do 3x times by x plus 1 times by 7 over, and then I'd have 3x times by 9x squared times by x plus 1, and then plus, and I'd have to multiply this side by 9x squared, so x times by 9x squared divided by 3x times by x plus 1 times by 9x squared. So you see that I have more factors in my denominator and I have more factors in my numerator, which ultimately we can get the same thing, but we're going to have to do more simplifying than what we did here. It's going to be a lot longer process. So, but you can always do that if you absolutely need to. But in any case, let's go to subtracting, and again, I'm going to show you through the method of finding the least common multiple in the denominator. So find the difference, which means we're subtracting here. So I'm going to factor my denominator. So I have x plus 2 over here divided by, and I can factor out a 2, and I get x minus 1 minus, and I have negative 2x minus 1 on the numerator here, and if I factor the denominator here, I need two numbers that multiply to be 3, but add to be negative 4, so that would be x minus 1, and then x minus 3. So if I take a look at my factors and my denominators, both of them, so think about what each one needs to be common. So this one needs a factor. So if it helps, so list all the factors. So I have a factor of 2, I have a factor of x minus 1, I have a factor of x minus 3. These are all my factors in both denominators. So this means that both denominators need all 3 if I'm going to subtract them. So this one right here is missing an x minus 3, and this over here is missing a 2. So I can multiply this over here, this left side, I'm going to multiply it by the one that is missing. So multiply the top and the bottom by x minus 3. And this over here, I'm going to multiply the top and bottom by 2. So by doing so, I get, so x minus 3 times by x plus 2 minus, and then I'm going to distribute this into both of them. So then that's going to be minus 4x minus 2. And this is all being divided by. So now that both terms, so you see how both of these have all 3 of the factors that I listed. So then I'm just going to write it as one denominator. So x minus 3, 2, and then x minus 1. Now I need to simplify the numerator. So I can distribute this, and I'm going to get x squared plus 2x minus 3x, so it's minus x minus 6. I can distribute this negative, so it becomes plus 4x plus 2 divided by 2 times by x minus 3 and x minus 1. So this is equal to x squared. Now I can combine like terms. So then that should be minus plus 3x, and then minus 4 divided by 2 and x minus 3 and x minus 1. Okay, now I'm going to move over here because I can factor the numerator into something new. So I need to find two numbers that multiply to be negative 4 but add to be positive 3. So that would be x plus 4 and x minus 1. And this is over 2 times by x minus 3 times by x minus 1. And you can see now that we have factors like those two that can cancel. And so I get x plus 4 divided by 2 times by x minus 3. All right. And that should do it for that one right there. Okay. So again, least common multiples, the method of the least common multiple is probably the best way to go about doing this. All right, now here are some examples for you that you can go over. I guess one that I would just want to go over with you would be number 11. So, because you see that we have 3 terms right here. Okay, now these first 2 terms are already factored, but let's see if I can factor out this one right here. So we have x over x minus 7 minus 2 over x plus 1 minus 8x divided by, so x, this would be, let's see, so it has to, 2 numbers that multiply to be negative 7 but add to be negative 6. That would have to be x minus 7 and x plus 1. So you can see how those are just the same factors that I have over on the other 2. So my factors in my denominator are these right here. Those are for all the denominators. So that's what all my denominators consist of. They consist of these 2 factors. So this one, in order to get the same, the next factor, I have to multiply top and bottom by x plus 1. And here I have to multiply by x minus 7. And then this one right here, I don't have to multiply by anything because it already has those factors. So then when I multiply these together, I get x squared plus x. And then I have minus, and then there's 2x. Multiplying these together, I get 2x plus or minus 14. And then minus 8x divided by, and now that I multiply these ones by the factors that they were missing, I have a common denominator of x minus 7 and x plus 1. And then if I simplify the numerator, so this would be minus 2x, and this would be plus 14. So then I get x squared, positive x, and a minus x, and a minus 8x. So that would be negative 10 plus 1, so then I get minus 9x. And then plus 14 over x minus 7 and x plus 1. So factor out the numerator now. So 2 numbers that multiply to be 14 but add to be negative 9. So that would be x minus 7 and x minus 2 divided by x minus 7 and x plus 1. And then those would cancel. So I'd be left with x minus 2 over x plus 1. Okay. So yeah, but I would go through some of these, try and work them out, and then I'll end this video here and come back for this last example.